more about that when I'm doing the problems. Probably run out of time at the end. The kinetic theory, I'm not going to ask you to memorize all 5 statements of it, but if you just picture in your head what's going on there, all right, in that little animation I showed you with the guy, you know, in a big box and all those molecules moving around. That's the kinetic theory. Everything's made of really small particles. They're moving around really fast, bumping into the sides of the walls, you know. The faster the more I heat them up, the faster they move. Okay. Now for gases, they're elastic collisions. They don't lose any energy, and there's no forces of attraction or repulsion between them. So those are, I just come up with the 5 statements right there off the top of my head. You will be given them and asked questions about them. You'll also be asked about the properties. I gave you at least 5, I think, properties of gases. You know, expansion, diffusion, all the different stuff. I talked about that. And definitions of new terms, like pressure and elastic collisions and things like that. Look over all those new terms. You do not need to know the definitions of, like, which one's Boyle's law, which one's Charles' law, which one's Gay-Lewis. You don't have to know any of that. You're just going to have to be able to use the laws. So don't memorize the name. Oh, Boyle's law means this. That's, you know, not necessary. What you do have to know how to use Boyle's law, but you're not going to ask for the definition of Boyle's law. I will ask you the other new stuff that you had in this chapter, new definitions. Okay? All right. What is there to memorize before I get to the problems? Things to memorize on this test. Let's take a look here. First, I would say you have to memorize 2 numbers. What 2 numbers do you kind of need to know to be able to do a lot of calculations to this? 7. Oops. 7. Here we go again. 760 millimeters of mercury. That is standard temperature. I'm sorry, that's standard pressure. It's also equal to 1 atmosphere. 273 is the other number. That's 273 Kelvin. Okay, you got to know those 2 numbers. You got to know how to use them. He's standard temperature, and you use them by adding him onto the Celsius to get your Kelvin. You use him by converting atmospheres, millimeters of mercury, torr. All right, so you got to know those 2. You only have to know really one equation. V2 P2 over T2 equals V1 P1 over T1. Why? Because all 3 other ones are in there. Cover up the T's. There's Boyle's law. Okay. You have just changes in volume and temperature, cover up the P's. There it is, V2 over T2, P1 over P1. So you just really need to know that one equation. So really there's 3 things to memorize. Now, I say, well, what about Dalton's law? You have to know that too. Not really. I mean, Dalton's law just says the sum of the pressures equals the total pressure. It's pretty simple. How many people were in this room? Add them up. It's that easy. All right, good enough. Now, let's do some of these problems now, okay? I want the volume. I'm given a pressure. Look at, I simply start writing my stuff down. V1 equals V2, P1, and P2. I don't have to write T's. Are there any T's in the problem? I'm assuming T is constant. I'm assuming temperature is constant. Your V1, your initial volume, is 40 milliliters. Your V2, what you're looking for is what volume. That's the unknown. The P1, the initial pressure, is 825 torr. Do be careful of how the question is asked. I'll talk about that in a second. And the new pressure is 2.0 atmospheres. Okay? I can convert either one. It doesn't matter. I have to have my temperatures always in Kelvin. But in this case, I can convert either one to the other. I can convert this guy to torr, for example. Atmospheres will go on the bottom. Torr on the top. 1 atmosphere contains 760 torr. And I would get what? What is it? 14. Wouldn't it be 1520? Yeah. 1520. 1520 torr. Okay? Then I simply set up my equation. Now remember, the only equation you have to memorize is V2 P2 over T2 equals V1 P1 over T1. But here, this is going to be V2 P2. I forget about T2. I don't have to write it down. Equals V1 P1, right? And what would I do to both sides? I divide both sides by, what am I looking for? V2. Divide both sides by P2. And there it is. Plug your numbers in, solve it. What'd you guys get? How much? 22 about? Somewhere around there? I'm not worrying about significant figures today. I'm not worrying about units. We've done that all chapter long. Just going over it really quickly. You should have gotten around 22. Does everybody agree with that? Okay. All right. Review days, we don't worry about all the details. Although on the test, you have to show me all the work to finish the work if you want full credit. Plug in all those numbers, keep in all your units, cancel out the units, keep significant figures. All right. Next one. Determine a new temperature, and it gives you a volume. So this time I'm just going to have V1, V2, T1, and T2, my initial volume. All right, now, I said a second ago I talked about how things are worded. Okay? This one said, you could always tell what's V1 and V2 by the wording. If something happens in the past, something happens in the future, that's going to be V2, V1. You could figure that out. Here it says determine the new temperature. Obviously, I'm looking for the temperature. If this volume of a gas at this temperature is changed to this, so this must be your V1 and that must be your T1. Your V1 is 44.1 liters. Your T1 is negative 40.0 Celsius. What did I do? I wrote that in the wrong spot. And that's easy to do. That's you got to be careful. I said it correctly, but I wrote it in the wrong spot. So do be careful when you're doing that. Your T1 is negative 40 Celsius. All right. What's your V2? It's compressed to 965 milliliters. I can't keep that way because I've got milliliters here and liters there. What would he be? Do I have to show the work for that? No. He's just going to be 0.965 liters. You don't have to show metric conversions anymore if you don't want to. If you need to, you can. What's wrong with this guy? Got to add 273 onto him. What's he going to be? 233, right? Right? Y'all remember to do that. I did notice when I just came back to your labs, several people in this class in yesterday's calculation kept Celsius instead of changing the temperature to Kelvin, and it cost them points. Okay? That was just yesterday's lab. You've got to always have your temperatures in Kelvin. All right, now this one's V2, P2, I don't care about, over T2, equals V1, P1, I don't care about, over T1. There's your equation, right? What am I solving for? I'm solving for T2. This guy down here, I just cross-multiply. T2, V1 equals V2, T1. Divide both sides by V1, right? And did you get that for your equation? If you got it to that point, and all you got to do now is plug your numbers in here, whatever they are, divide them out. If you got it to that point, you do that. You can't lose a whole heck of a lot of points. Okay? You picked everything out right. You made your metric conversions or whatever other conversions you had to make. You set up the equation. You rearranged it algebraically. You got it set up right. All you can do now really is a calculator mistake, which will cost you a point. It's not going to cost you much on this test. All right. What's next? Mixture of gases. I mean, this was so easy, it seems hardly necessary to do it, but real quickly, I have a mixture of gases, and it has a pressure of 1, so your P total is 1.86 atmospheres, right? Calculate the pressure of the missing gas. If you know A is that, what's the only thing you have to worry about? Just converting everybody to the same unit. So I would have converted my torr to atmospheres, right? And then you would have subtracted away. That one's, we just did that yesterday. We just did it the day before yesterday. I don't need to do another one of those, okay? How about this guy here? This guy I do want to do because he has everything in him, pretty much. He has Dalton's law. He has the combined gas law, the full combined gas law, all right? And it says it's collected over water, which is how we collected our gas yesterday, all right? And how we're going to collect all of our gases from now on. So I'm going to write this guy down. V1, V2, P1, P2, T1, T2. This has got everybody in here. My initial volume is 350 milliliters of gas, and it's collected over water. That's important. We'll get to that later. V2, it's what I'm looking for. What volume will it occupy? P1, my initial pressure, all right, is 832. It has a pressure 832 millimeters of mercury. All right. And my P2, it says collected at, what will it be at STP? That's going to be 760 millimeters of mercury. My T1, my initial temperature is 25, and my T2 is 273 because it says at STP. That's what it means. STP, standard pressure, standard temperature, Kelvin. All right, got a problem with this. Couple of problems. Number one, I got Celsius here. I add 273 onto him. It gives me 298. But my other problem is this guy, you don't realize it. You say, well, what's wrong with them? There is, because he was collected over water. I have to subtract away the water vapor pressure at 25 degrees Celsius. And what is that? As you look at your sheets, look at it. If you didn't do it, you're not going to do it tomorrow either. What'd you get? 23.76? Okay. Now, look what I did there. Again, I'm going fast, and that's what happens when you try to go too fast, putting stuff in the wrong spaces. I'm subtracting that from where it was collected over water at this pressure, which was 832 millimeters of mercury. And we said it was 23 point what? 76. Now, this number is not an exact number. I've got to round up. 832 only has, 3 significant figures and no decimal places beyond that. So I'm going to pretty much round that guy up to 24 and subtract him from there, and I would get whatever that is. 808? Okay, millimeters of mercury. All right, now real quickly, because I don't have too much time left, I want to still do those other two we haven't seen in a while. V2, P2 over T2 equals V1, P1 over T1. I have to rearrange this guy and solve for V2. I'll multiply both sides by T2 over P2. Right? And if you got it to this point, so V2 would equal V1, P1T, I can't read my own handwriting here. I'm writing P2 over T2, right? T2 over P2. That's T2 over T1 P2. Is that right? I can't read my own writing here. If you got it to that point, and then you plug your numbers in and show me all that work and do the math, again, not many places you can go wrong there. Where are you going to go wrong? You're going to forget the water. Oh, collected over water. You're going to forget conversions. You're going to pick things out wrong. That will be your more common mistakes. Once you get it to this spot, not mine. Oh, let's talk about that one mistake you can make here. You ready? This times this times this divided by that times that will give you the wrong answer, won't it? Yeah, you got to either put parentheses around here or just this times this times this divided by that divided by that. You can do that. All right? Okay. Now, the last ones are ones we haven't seen for like 2 weeks because of all the delays and everything we've had with this crazy winter. How would you do this guy? Okay? Remember how to do him? I hope. Maybe. Maybe not. R1, R2, more mass 1, more mass 2, right? You do that? Did you look it up? Okay. What's your, okay, it wants to know the more mass of a gas that diffuses 1/10 as fast as hydrogen gas. So 1/10. If I make him 1 and him 10, right? Did you do that? Is that how you made your things? Okay. So this guy's 10 times faster, right? The other guy's going to be slower. So my rate 2 is going to be the faster guy, which would be hydrogen, which would be 2.0158, I think. Is that right? Where did I get 2.0158 for a molar mass? Why isn't it just 1? Why isn't it 1? That's just 1 up there. Yeah, because it's diatomic, H2. Don't forget diatomic elements. You all good with that? All right. So is that good? Everybody got that? And this guy is your what? Yeah, it's your no, it's your X. All right. Your equation is rate 1 over rate 2 equals molar mass 2 over molar mass 1 square root, right? Got that? Plug in my numbers. I got 1/10, which would be 0.10. I can just do that for me. Equals 2.0158 over M1. All right. Square both sides, correct? If I square 0.1, what do I get? 0.1 times 0.1 is what? 0.01. Am I doing this right, by the way? My math, I'm doing it in my head, so I want to make sure this is all, everybody's been doing this. That's 2.0158 over M1. That's your molar mass 1. Multiply 0.01 times molar mass 1 equals 2.0158. You're going to divide that into, it's going to be you're going to get 201 or 206, right? 202. Let me round it up. Is that right? So your molar mass of the missing guy should be around 202. Okay? When you do the math for that. It's just going to be 0.01x equals that. So you divide by both sides by 0.01, you should get about 202. All right, how about this guy right here? Last one, we only have 4 minutes, 3 minutes left. Okay, how about this guy? Same thing, R1, no, that's wrong. R1, R2, M1, M2. This one's solving for something different. Okay, I want the ratio. I want how much faster or slower. All right, first of all, I know which one's going to be faster. The helium. All right, let's call him M1. It doesn't really matter. We could do it the other way, but if you call him M1, all right, it makes more sense. And he's molar mass is 4.003. And argon's is 39.948. This, I can leave both of them blank because all it's asking me for is which one, the ratio, basically, how much faster. So R1 over R2 is going to equal square root of M2 over M1, right? And you'll get, when you solve that, what are you going to get? You have to do all the algebra and everything. What do you get? Anybody get? 3.16, I think, was the answer. Is that right? All right. All you do is plug your numbers in. And actually, this whole thing will be 3.16, which means it's 3.16 times as fast as the other guy, right? That's how much faster he's going to be for the diffusion. All right, good enough. So I would recommend, I'm telling you right now, on the back of this test, there are a lot of questions and definitions. I would recommend studying over those notes, especially under the properties and the kinetic